One was submitted. We couldn't print it, it ran out of ink today.
All right.
Now, 4:30
Yes.
on December 17th. This is a meeting of the Water Quality Management Committee. We have a agenda that is focused strongly on the concept of attenuation, how it occurs, where it occurs, and it will lay some groundwork that will, I trust, get incorporated into the watershed management plans as to where the priorities might be, and future Board of Health action as to where other folks will need to be upgraded to an IA under certain conditions. First item on the agenda is to hear from Kevin Kroger. Kevin is a recognized scholar when it comes to soil, groundwater. You were at the USGS for a number of years, Kevin?
Yeah.
Please step to the microphone. You know, he also chaired the Board of Health, but he's here tonight to sort of summarize a paper you wrote close to 20 years ago now?
Yeah, everything I'm going to show you is really old. Yeah.
Like us.
Yeah. So I can see already, based on conversation with Ken on the walk-in, I didn't exactly prepare a presentation on that paper. I brought in other materials to talk about more broadly the topic of nitrogen attenuation.
Yeah.
So for people that
We just, the paper got distributed to everybody on the board, so
Okay.
I'm sure they've read it and will have many detailed comments on some of the, you know, assumptions. And
Ken can probably, he just read it again, he can answer them for me. But so for people that don't know me, I came here in 1997, did a PhD in the Valleyella lab at Boston University, postdoc to Woods Oceanographic Institution and at USGS down in Tampa Bay, Florida. Came back to the USGS office here, and I'm just wrapping up at the end of this month, 21 years at that office and doing an early retirement there. And I'm working now with the Yale Center for Natural Carbon Capture and a couple of private companies called Sylvestrum Climate Associates and Vesta, and guest investigator at Woods Oceanographic Institution as well. And my work since 2012 has been on climate change mitigation, coastal ecosystems, enhanced weathering of minerals to capture carbon dioxide and mitigate methane emissions. But before that, from 97 to 2012 and sometime since, the focus was on nitrogen loading from watersheds to estuaries. And so you can see in this graphic, everybody's probably seen this graphic. This is from the Valleyella et al. Nitrogen loading model, showing the main sources of nitrogen to a watershed: atmospheric deposition, fertilizer applications, and wastewater, and then the pathway of transit through the watershed into the estuary. And so we see the arrows going through what's called the vadose zone and the soil. So the vadose zone is unsaturated mineral soil above the water table. So the water and whatever it's carrying, the nitrogen, the organic matter, all percolates through that, in this case, sand and gravel aquifer, right, before it reaches the water table. And then it transits in a more horizontal direction towards the estuary and discharges through what we can call the seepage face or the submarine groundwater discharge zone into the estuary. So that's the path. How do I advance slides?
There's a keyboard.
you can pull it out.
Okay.
And there's standard. There we go.
Thanks. Yeah. So I think there's agreement among just about everybody that there's a certain amount of nitrogen removal in these two blue circles in the septic system, moderate if it's a standard Tidal V system, and then also in the plume as that water, the initial transit of that water and nitrogen through the groundwater. The length of that active zone with denitrification in the plume, I imagine this committee's thought about that a lot more than I have in recent years. But what I think you want to know about is that first red circle, how much nitrogen might be removed in the groundwater during longer transit. And then I'm going to note as well that there's loss at that seepage face as well. There's evidence for that. And so I'll talk about both of those, really starting with that seepage phase first. So I'm going to show some data, and it's going to get a little bit technical, but don't worry about the more technical details. Show some data from several sites, several estuaries around on Cape Cod, Great Pond, Green Pond, Eel Pond, Childs River, Quashnet, Hamlin, Yehu, Sage Lot, and then some of the systems over in Papaneset Bay as well. And Coonamessett Pond, even we sampled around there. And the methods, a lot of the methods are about sticking a rod with perforation at the end into the...
One thing, just spin the microphone towards you because
Gotcha.
we are on TV.
All right, I'll stop stepping out.
I don't think they pick you up very well.
Okay, thanks. In addition to the Cape Cod sites, 3 sites on Long Island, New York, which is geologically very similar to here in the state of Delaware, quite a bit of work there, a little bit in Maryland, and then some work in Tampa Bay as well. So these are all sandy aquifers with nitrogen from these various sources moving through them. And so we use these rods and we go through the up above the tide, through the tidal zone, into intertidal zone, and into the subtidal, and we collect a lot of samples and we analyze the chemistry. And so this is what it looks like at the discharge zone to the estuary. I can't help it, I'm gonna keep walking towards that screen. So in the top left, that's salinity, okay? And so we're looking at a cross section through the head of Ocoee Bay, and the white zone is fresh groundwater coming underneath the unsaturated sediment above it, and then discharging into the estuary. The red indicates salt water, and then we have a mixing zone between those. We have a mixing zone shallow, and we have one deeper and a little bit farther off. And on the top right, we have nitrate concentration, and on the bottom right, we have ammonium concentration in those zones. And so we can have nitrate or ammonium moving in plumes of enriched groundwater towards the coast. And you can see under the saline zone, it's all ammonium. So in general, when we talk about nitrate, that's going to be oxic conditions. And when we talk about ammonium and organics, a little different, but it tends to be under more chemically reducing, low oxygen or anoxic conditions. So, going to talk about those forms of nitrogen for a minute. Here we have, on the y-axis, we have redox conditions, or is the water reducing or oxidizing? So at the top of the graph, that's oxidizing. There's lots of oxygen around. The bottom of the graph, there's little or no oxygen. And then we have pH on this graph. And the reason we put these two together is because they show us the thermodynamic stability of different chemical compounds. And what we see, this is comparing data from the head of Ocoee Bay and Tampa Bay. And the Tampa Bay system is very different. It has a lot of ammonium. It tends to be very chemically reducing, suboxic and anoxic in the groundwater. And so thinking about why are these different, we can see that mostly the compounds conform to those thermodynamic stability limits. Mostly have ammonium in the ammonium stability zone. We never get up into the nitrate stability zone. Throughout all these samples, at most we're in the nitrite zone, which means nitrate is just barely stable in the groundwater in a lot of locations. So what that means is it's almost reducing enough to reduce it and convert it into N2 gas, the denitrification process that we're interested in. So it's a difficult place for nitrate to persist. We can look at this in a different way. On this y-axis, we have the percentage of the inorganic nitrogen that's as nitrate. So this is nitrate divided by the sum of nitrate and ammonium. And you can see that throughout this whole reducing area, and even up to a fairly oxidizing zone, it's almost all ammonium. We don't get any nitrate until it becomes more oxic at the right side of that graph. And again, conforming pretty well to the expected stability zones. So why do we have those differences? We can look at, and this is not random, we already had information that suggested that the thickness of that vadosome, the unsaturated soil above the water table, has some influence on all of this. And so what I'm showing here, this includes data as well from, I think, this also probably has Long Island, New York data on it, which some of that I'll show in a minute. So on the top graph, we have redox conditions again. Higher on that graph is more oxic, lower on that graph is more anoxic. And we can see that we don't get the really reducing conditions except where the vadosome is quite thin. So in other words, the water table is very close to the soil surface. And then when we get a little bit thicker vadosome, up to 10 meters, 20 and on up, it's more oxidizing conditions. And we can see again that percent of the inorganic nitrogen is nitrate, conforms reasonably well to those controls. So we have thin vadosome, high water table, a lot of ammonium, and then we have thick vadosome, deep water table, and a lot of nitrate. So here's where a lot of this data comes from. This also has Cape Cod data on it. But if we look on the left top there, we have Manhasset Bay. That's near the glacial moraine. A lot of the watershed is, you can see. Long Island's just like Cape Cod, same. And then on the top right, you have Northport Harbor, also on the moraine. And on the south side, we have Patchogue is the name of the town, and that's in the outwash plain. And so the outwash plain has the thin vadosomes and more ammonium, not much nitrate, and the other sites have mostly nitrate in the groundwater. So that's just noting that that's different than the classic conception of how groundwater and aquifers work in terms of chemistry. Here, this is from a Slomp and Van Capellen product, but it's maybe originally from a classic textbook. And what they're suggesting is that the more time that the groundwater spends in the aquifer traveling into deeper flow paths, it becomes more chemically reducing. We see exactly the opposite here. We see shallow, young groundwater near the soil surface being very reducing, having mostly ammonium, and we see that the deeper groundwater underneath the thicker vadosome typically having more oxic conditions. So what about nitrogen losses? Just briefly, in the discharge zone to the head of Wacoit Bay, we have mixing between, on the left, the nitrate plume with dark circles, and an ammonium plume with open circles. And actually I think those, no. Yeah, okay, never mind. So that's correct. And just showing briefly that on the right, that the stable isotope ratios go up, get heavier as we have apparent loss during the mixing of these two plumes. So it's not an even mixing, it's a non-conservative decrease in concentration, and the isotope ratios go up. And I could say a lot more about that, but just when we get the right water masses mixing together in that discharge zone, we tend to get some denitrification and some removal. It looks like it can be significant. So the 3 Long Island sites, throughout all of these sites, we collected samples and measured the concentrations of N2 gas and argon gas in the samples. And I have to acknowledge Ann Giblin and Jane Tucker at the Marine Biological Laboratory for making their instrument available to measure these, especially Jane, who's the one that pulled her hair out to keep it running. So N2 is the product we're thinking about when we talk about denitrification. There are other processes, we could call it just microbial N2 or just excess N2 gas in the groundwater as an indication that it was either nitrate or ammonium or organic nitrogen, and through chemical processes ultimately became N2 gas. And then it's inert, it's going to be lost up to the atmosphere. Eventually it's out of our way in terms of eutrophication. And the argon is an indication of how much air is in the sample. It's just a passive tracer of air content, which tells us the temperature it was recharged at, the elevation, how many bubbles are dissolved, all those sorts of things. So we use the argon and other information to correct for those. And so if we have more N2 gas in the water then the argon would indicate that we should. That means there's been denitrification happening. So that top graph, that's from the Patchogue site on the south shore of Long Island, out on the glacial outwash plain. And you can see way off to the right, the x-axis there is the N2 gas and the y-axis is the argon gas. There's a lot more N2 than we expect. In this graph, we expect as much N2 as in the solid circles there. If it were totally conservative, it would be falling along that line. There's a heck of a lot more. 200 micromoles of N2 gas indicates 400 micromoles of nitrate denitrified and 71 micromoles per milligram. So what's 40 divided by 7? Shouldn't have said, so 6, yeah. So 6 milligrams denitrified there, quite a bit or more. And then if we look where we have a somewhat thicker vadose in the middle here, we do have some excess N2, but it's less. And then when we have the thickest vadose, again, where there is some excess N2, there's been some denitrification, but a whole lot less. And summarizing that a little bit more.
So you're assuming that's because there's no anoxic conditions that exist to convert the nitrate to N2?
In the thick vadose area, yeah, exactly. So summarizing all this a little bit, the top right graph is redox conditions, again, on the y-axis, and vadose thickness on the x-axis. And you can see that it's reducing with thin vadose, oxidizing with thick vadose. Oxygen is similar, though it's a little bit messier on the top right. Dissolved organic carbon, which is the organic matter source that would drive denitrification. If you don't have any organic carbon, you generally are not going to get significant amounts of denitrification. Dissolved organic carbon shows a very strong relationship with vadose thickness. So we have a lot of DOC that is able to make its way through the soil, through the unsaturated zone, and into the groundwater when the water table is shallow. Then it can drive denitrification. Then it can consume oxygen and cause reducing conditions. Where we have a thick vadose, I mean, just imagine passing some wastewater through 60 meters of a sand column. And it's not just a saturated sand column, it's an unsaturated, air-filled sand column that it's passing through. Almost nothing survives that except for oxygen and nitrate. That's about it. So we have very low DOC, and then we have a lot of denitrification where the vadose is thin and much less where it's thick. A student at Stony Brook provided a further hypothesis on why the unsaturated zone thickness would matter, which has to do with reintroduction of new oxygen into the unsaturated zone when weather fronts move across a landscape. So you have 50 meters of air inside the pore spaces of some sand and gravel. You get a high pressure front coming through it, compresses that air column that introduces new air with new oxygen. And then when the low pressure comes through, that springs back up and it refreshes the air over time. You can imagine if you had a unsaturated zone that was only 2 meters, the degree to which that spring would compress with those pressure fronts is going to be a lot less. And importantly, if that compression happens below the O horizon and the organic rich parts of the soil, then you're adding new oxygen into a sand column where there's no organic matter to consume that oxygen later. So, vadose processes have important influence on redox conditions and therefore nitrogen speciation. Losses of nitrogen in the aquifer are primarily through denitrification. There's another process, but it's not worth talking about. Loss is greater when the vadose zone is thin, the water table is shallow, and smaller when the water table is deep. Vadose zones are thickest on the moraine and near the moraine, and thinnest in the outwash plain near the coast. This might suggest greater nitrogen loss in aquifers from septic systems and watersheds that are near the coast than from systems that are farther away that have to transit through a thick unsaturated zone. But there's uncertainty in any one location in terms of how much nitrogen loss is going to occur until you go measure it. There's also, as this committee knows, there's a lot of uncertainty in groundwater transit times as well. So we've been looking at groundwater transit time maps, but we know there was a lot of uncertainty in how long it would take the plume from the wastewater treatment plant to reach Snug Harbor in West Falmouth Harbor. There were estimates, and then those got longer over time as we're waiting for changes. It's maybe harder to predict groundwater hydrology than it is to predict the behavior of nitrogen, I would suggest. So there is uncertainty in these things. But I have this map, Don Walters at USGS provided for me when I was a grad student, of the vadose zone thickness, the unsaturated soil thickness for this area of Cape Cod. And you can see that up on the moraine, it's very thick and thins towards the outwash plain and towards the coast. And so that leaves us in a maybe somewhat unexpected position when we want to decide whether to use distance from the coast as an indication of how much nitrogen load we expect to the estuary from a particular septic system. This is different, I'll note though, from the question of how much nitrogen is removed very near the septic system in that plume that's close to it in the initial transit period. And I haven't looked at literature on that recently. I'm not sure if that's been part of the discussion here. It's kind of a separate issue. If there is significant nitrogen loss immediately in the young plume right after it's left the septic system, then you would want to manage the septic systems that are very near the coast, whatever that number is, if it's 100 meters, 200 meters. But beyond that, a more nuanced approach to managing based on proximity to coast, I would say there's a lot of uncertainty in doing that.
Excellent. Yeah.
I think that's it.
Yeah, but we're just really sort of picking up and tackling, what's happening with the nitrogen and, so you feel like I just got a master's course in what may or may not be happening. I don't know if anybody else. Ken?
Well, I had several things that I thought about. First, regarding West Falmouth Harbor, that's a 100-foot thick vadose zone, where the Falmouth waste treatment plant is.
Yeah.
So it's not surprising that it's all nitrate by the time it gets down to the water table. And it actually seems to take like 2 years or more for that
to get there,
to transit that vadose zone.
Wow.
And I think there's might be some retardation in retention somehow.
Yep.
in the vadose zone, so that even after you stop, inputting nitrogen, it continues to kind of seep out. Because, we found based just on the time from the initiation of operations, when they started spray irrigation at the wastewater plant, to when the well 19 saw the first increases which is at the shore. Well 19 is a town well, goes down approximately 80 feet right at the shore, was 12 years. So even though the groundwater flow model said it's 7 years, it wasn't 7 years. And then once they added the denitrification module and drastically reduced inputs from the plant from down to 3 milligrams per liter, and a similar really slow response observed at the shore. And only in the last few years have we really seen, in that same well, 19, meaningful declines.
Go ahead.
So that's one observation, just from that particular location. But even in the areas where we have thin, what you probably would call thin vadose zones, around Little Pond, on the western shore of Little Pond, it's primarily nitrate. If you get into the peninsulas near the ocean, you're getting ammonia.
How thick is the vadose zone?
Well, I assume maybe, so that was going to be a question for you. How thick does it have to be before you get to nitrate? Say it's 10 or 15 feet.
Yeah, so it's 15.
That's 3 meters.
5 meters. It's going to be in this range, right?
Yeah. Yeah, so it ramps up very quickly.
Yeah, it's a steep slope. Yeah.
So for all intents and purposes, I think.
Most places.
Right. And your own data, one of your other papers I looked at, and something like 70 to 80% of the total dissolved inorganic nitrogen was typically, on average, was nitrate, right? So.
But there are locations where it's not.
Yeah, if you get down to, well, in the area that I'm most familiar with recently is that, down the end of Mara Vista Street there, that's almost 100% ammonia in our wells.
Oh, is it?
Yeah.
Locally recharged.
If you get down deeper than a meter or two, you're into ammonia. But you're also into saline waters. So it's your observation about the relationship between salinity and ammonia is spot on there.
Yeah.
But the thing that I think we have to think about, though, is regardless of what the science says, right, is that DEP, from the point of view of loading, has taken a very conservative attitude. We're not, they're not going to give a lot of credit for attenuation, because I think there's so much uncertainty about how much attenuation may or may not be occurring. So the whole MEP process really ignored, for the most part, attenuation, except for this number where they said if the water enters a surface water body first,
Yeah, you get some.
then we're going to say 70% is lost.
Right, and that's the MEP model.
Right.
Right.
Even though Ivan's model says there should be some attenuation along the flow.
And I am from that camp,
As
but I
am I.
am looking at the data in an objective way, and it's quite obvious. There's a lot more N2 gas with
That's on Long Island.
different question. Well, yeah, but the main point is, even where you have a thicker vadose zone, all of these points that are falling to the right of the solid solid symbols, even where you do have a thick vadose zone, there's removal. I mean, those numbers on average are maybe 20, which would be, half a milligram, maybe, a little more. So there is removal, there is denitrification, and
I don't.
I know, and I'm just saying
But I just don't think we get credit for it, and I
Yeah.
don't think we will get credit for
Yeah.
it. Because there's too much. It's like when you build a bridge, right? You don't build it to be exactly the strength needed for N cars. You have a safety factor.
Yeah. I mean, this one as well, losses at the seepage face are obviously not in any of the models. But I'm not totally sure what that means. If the model assumes more conservative transport and therefore a larger load than what we think is real, and yet the estuaries are in whatever shape they're in, then maybe the idea that we've been overestimating loads means we've been underestimating how sensitive the estuaries
Well,
are.
that could be. I came to the conclusion a number of years ago, it really doesn't matter what the exact number for loading is, as long as we use consistent criteria, we
Yep.
know the impact on the estuaries.
Yeah.
Right? The other thing, one other point I would make is that almost all the areas where we have severe impacts along the south coast and the outwash plain, very high-density housing, very near the shore. So there's not much transit time, and thin vadose zone, comparatively thin, but thick enough to get nitrate, and there probably isn't time for a whole lot of denitrification.
Right.
And, again, looking at what happened in the Little Pond system, almost the response in the groundwater was within a year or two or three of when the sewers went online. It was very rapid, which frankly surprised me. But actually, that was consistent with some of the USGS modeling for that same peninsula. So,
Yeah.
anyway, those were my comments.
Good, good. Other members of the board?
Yes, I've got a couple of questions. If you've got a saturated water column that's this thick inland, and it becomes compressed because it's got salt water underneath it as it approaches the shore, what happens to the horizontal velocities of the groundwater under that condition? Do you get jetting?
If by jetting you mean acceleration?
Acceleration, because you're compressing it vertically.
Yeah.
Because it's trapped between the upper soil, or the water table, the top of the water table, and the salt water that's underneath it. And then the other thing I'm thinking about is the effective thickness of the vadose zone is much greater than its vertical depth, because the water particles are moving at an angle, right? None of them are moving vertically, right? And the only mixing forces there would be diffusion, right? There's no turbulent mixing.
No turbulence. Just one point on that. Usually we assume that before water hits the water table, the ocean is vertical.
Vertical, right, yeah.
Yeah.
So that's the
And it's-
depth of vadose zone, and then it
Yeah.
slides off horizontally.
Yeah.
Jonathan? Yeah.
I guess I had a question on the paper I read.
Okay.
Maybe not exactly related to this because you focus on the vadose zone here, but in the paper, it seemed like there was nitrogen loss through the phreatic zone, because as you go along the horizontal pathway of groundwater flow, and in your example, you have about 5 kilometers of flow from the source to the sink, you get a decrease in the amount of nitrogen that's present. So as you get really close to the source of the injection of the nitrogen, by the time that's reaching its final depositional spot, you've lost 80% or so of the nitrogen. So clearly there are processes of attenuation, denitrification that are occurring in the aquifer.
Yep.
How do, I mean, but you focus in this case on just really the Vado zone, so you really have to put all that together to come up with what you think the final attenuation is going to look like along the flow path of the water as it reaches its final resting spot in the estuary.
Yeah, yeah, and, you know, I haven't myself tried to reconcile this work, which came after the work you're talking about, which was the Ashuman Valley plume and the West Falmouth Harbor plume. I don't know exactly what I mean, you just mentioned in West Falmouth Harbor, the unsaturated zone is really thick. So why would we get removal there? I'm not really sure. It may be, you know, it may be that the way we think about it is that the thickness of that unsaturated zone is a powerful control on the chemical conditions in the groundwater, in that aquifer. So it's going to influence both the rate and the extent of denitrification, of nitrogen removal. But that doesn't mean that it's going to prevent it altogether. So even if you do have a thick unsaturated zone, and we see that in our thickest, on Long Island, that unsaturated zone is quite thick. Where was that? Yeah, up to 50 meters. You still get denitrification. So if you have a thick vadose, a low rate of denitrification, but a very long flow path, then you're going to, over time, you're going to remove some of that material. And there's, you know, we have to remember too that there's organic matter or other chemically reduced compounds in the aquifer itself, other than the organic matter we're introducing from the surface, and those can drive nitrogen loss as well. So I think that would suggest that there is an interplay between the idea that from areas farther from the coast here, thick vadose zone, low rate of denitrification, but very long flow path, and therefore more time for that slower rate of denitrification to occur, versus thinner vadose zone and a faster rate of denitrification and a less time for it to occur. What the net of that is, I don't know.
Well, I think your paper shows it. I mean, it clearly, you know, the relationships aren't, you know, the R squared isn't very good, but the overall logarithmic curve fit to the data shows you're going from 80 to 20% nitrogen lost over that, you know, 4 or 5 kilometer flow path. So it's clearly things beyond the vadose zone that are causing denitrification, and significant denitrification.
Yeah. And that had, you probably remember, and I don't know what the length of that flow path was.
About 5 kilometers.
Yeah.
Yeah, but when the shorter the flow path, the less nitrogen is lost. It's intuitive that, you know, along the flow path, you're getting denitrification. Then the longer flow paths, you're losing 80 to almost 100%.
Yeah.
So it's having a major role, the phreatic zone.
And that graph, as you mentioned, it has a logarithmic shape to it. There's a wide spread closer to the source, and then it narrows to a higher rate of loss farther from the source. The other thing that we don't know from that is what the water's encountering when it gets farther from the source. Could be encountering and mixing with water that's recharged from different locations. You know, it's because there's the continuous recharge on top of that water. Right. And although mixing is limited, it's not nil. It does happen, especially with a 5 kilometer flow path. That's a long time. Mm-hmm. So that could be a factor as well. But, you know, we don't have very many places with a 5 kilometer flow path, I think. It's uncommon.
Can you go back to I think it's your very first slide, the schematic diagram?
First slide, that?
Yeah.
Okay.
Now, there's only one house here, but it's got some of the geometry I want to allude to.
Okay.
If there was another house further upstream over to your left, on the other projector, for instance, is the effluent from that in addition to going through its independent path to get to here, does it then go in the same place to get to the estuary, or is it underneath? Because to the extent that it's in the same place, then you don't need any math or any chemistry, the simple logic to say that the stuff coming from further away has all the same things happening to it that the stuff coming closer has, plus the extra on its way to get there.
Yeah. So as you can see, these lines that are curving once it hits the water table, what that's indicating is that when water hits the water table, it will immediately start to move mostly in a horizontal direction across that water table. And then when new water comes in on top of it, you add more layers, right? And the older water gets deeper while new layers of water get added on top. But there is mixing. It's not like they don't mix at all. There's a certain amount of mixing. And so that older plume from farther away, if it's pretty close to this house, could easily mingle to some degree with the plume from this house, particularly because this is one of the things that complicates what we're talking about here too, is the way the groundwater behaves in a developed landscape is different than it would in a natural landscape. Working with the USGS Water Office in Northborough, we did a study here on Eel Pond several years ago, and then they did one a little bit farther out east and on Great Pond, I guess, which I wasn't involved in. But there was a lot of discussion about whether plumes of water leaving a septic system are denser than water in the ambient, because they got a lot of salt in them, right? And so they may dive deeper through some of the native water that's there, in which case predicting their behavior exactly is harder. But we saw features out on the Eel Pond, Eel River watershed right at the coast that were a little hard to understand, including some extremely high nitrate concentrations that wasn't clear where they came from.
Well, it's impressive work, and the chemistry is way over my head. But
Thank you.
there's so much variation. Is there any way we could use any rule of thumb from this in designing? And you can't say more research is needed.
No, I'm not going to say that. I don't even do this anymore, so.
The decision, any value we get from this, we have to get now.
Yeah, understood. So, I think if it were me and I were just coming up with something, I would think about the houses that are very close. And we could look at the literature. I haven't done that, but the reason the Valleyella model talked a lot about the houses closest to the coast was because there was an understanding based on the literature that was used to develop that model that in the plume immediately after the septic system, there's a particularly high rate of denitrification. So you wouldn't want to truncate that and put septic systems right on the coast, right? Because then they just go straight in with no chance to be attenuated. But so how far in to go? I don't know. I don't know if it's 100 meters, 200 meters. It would be worth looking at the literature on that. There's a lot coming out of that. There used to be a lot coming out of Canada on that topic. And then beyond that, if it were me, I would treat them all the same because there is a lot of variability and maybe interacting and counteracting processes. Again, transit time versus rate of denitrification. It's going to make it hard to predict.
Anybody in the audience have a question? Okay.
No?
No. Okay. Jed got his hand up before you, but you're next.
Peter Hargraves, Precinct 9. I'm so out of my element here, but trying to reduce it to the things a citizen can grab onto. I'm wondering if what's been said a couple of times, and the last thing that was said, means that we have to question how worthwhile it is to put IAs into systems that are miles away from the shoreline.
Okay, thank you. Jed,
Not a bad takeaway.
you need to step up to the
I
microphone.
know, I'm just trying to think whether I should. I think for regulatory reasons, I cannot speak.
Quorum,
Because there are,
Board of Health.
we have a quorum of the Board of Health here, so I can't.
But you're not, I think you're fine, because you guys aren't discussing or debating something that's a Board of Health issue. You're going to stand up as a citizen to talk to this conversation. You can. At least my opinion would be you're not.
You're also in public. You're not hiding it. You're not having a secret meeting of the three of you.
And I could leave, because.
No, I think it's okay.
It's your choice. I'm just saying.
Well, it's more of a comment to this. All right, fine.
Yeah,
Jed Goldstone, Precinct 2.
and we'll caution Kevin not to respond to your comment.
That's fine. This is so I want to actually agree with Peter that this is a $100 million question, as at least $100 million. Well, no, the immediate question of how many IAs to put in is about a $100 million question. So this is not a trivial difference from what the MEP, the debate over the MEP model, or using the most accurate, most recent data and science to support a very, very expensive decision and plan. And so I just want to encourage you, when thinking about this, to think about it as a $100 or a $150 million question, and to put it to the state that way. Not to put it to the state that, the difference between a model that was developed 25 years ago and one that is more accurate is not a trivial question.
This is like the first meeting where we've kind of asked this board to get information on what's happening beyond the past models, which were very static. Each home has this number times this expected whatever. We're now trying to take it to another level because we recognize we're going to be making decisions about how fast and where IAs go in, and we're trying to get as much of an understanding of what's truly going on. And just hold your horse for 1 second. The next piece we're going to pick up right here is going to at least touch upon what some other communities have done, in terms of Board of Health regulations, which don't appear, from anything I can look at, to be sort of scientifically based. They're just like 100 sounds good, or 150 sounds good, or 50 sounds good, And so we're recognizing you guys have done, in the Board of Health, you put a regulation out there. Mm-hmm. It's not the last regulation I think you're going to have to put out. So we're trying to get a conversation going. This is, to me, it's phenomenal. I hadn't even thought about everything going on in the Vados zone, and some of what you just said to us tonight is kind of an eye-opener about, I would have thought, a deeper soil column would be better, and what you're saying is no. You want to, it keeps working and doing something, but really the shallow one is in terms of the whatever. So that's where I'm at. Go ahead, Steve.
Well, I like Jed's comment, and I think the obvious response to it is to ask everybody, what about the following approach? If the totally conservative approach was to put in, let's keep the numbers simple, 100 IAs, that's representative of many more, over 20 years, then if you draw lines around the estuaries moving further and further out in increments of 1/20th of the total amount, and you start near the shore, and each of those 20 years you put in that many IAs, until either the 20 years is up or you've noticed that the estuary is clean or is obviously going in the direction of clean. Is there anything wrong with that?
It's a concept. Concepts are not wrong. All right.
Can I respond to one of the comments or no?
Absolutely.
So just Mr. Hargraves, so I just want to be clear that this bottom left graph here shows very little in the way of nitrogen removal in the watershed. And that one is similar to something up on the other side of 151. Okay, it's up towards the moraine high. Not much nitrogen removal. This one is more like something out closer to the estuaries on the top left, has a huge amount of nitrogen removal, and it's like the areas in red with the thin Veda zone. So I don't know that we have science to tell us that there's no reason to put an IA on a system north of 151, and there's every reason to put one on a system south of 28. We don't have any data to tell us that that's better. And I think that some of the picking numbers out of the air that you were talking about, Steve, I saw the one from maybe it was Chesapeake Bay where there was 30% assumed loss, 50%, 80%. Those definitely are made up numbers. There's no way that those are based.
I was referencing that other communities around here, Tisbury, other places, Mashpee, they've had their own Board of Health setback regulation. One of the things that we'll get to see over the next several years is in places where, Tisbury's put it in, then we're going to start getting a count. How many homes have been converted over in Tisbury? Where are they located? Is there a change in the nitrogen concentration in the receiver? We're going to be able to maybe reverse engineer or reverse, if you say, oh, there's, 200 homes went in around whatever in Tisbury, X distance, Y distance, and the nitrogen numbers have dropped down. It's kind of like what happened in Little Pond, Ken, you have some great little things showing the changes in time as a function of sewering. We're going to, I think, over the next few years, because people are doing this now, it's slow, but it's starting to happen. We will be able to see, and that will help too, because we got a 20-year period to put things into place. We're going to get watershed plans, and the watershed plans are going to recommend things in 5-year increments. What that'll be, whether it's, something new every year for 20 years, or whether it's something new every 5 years, or what it is. The watershed plan is going to pop some of that stuff out over the course of this year. And then as we implement those things, hopefully, because a couple communities are ahead of us on the watershed planning, particularly when you get down to the Orleans end where they're doing certain things already, we can start to see how water bodies are responding. We'll go from watching things get worse to seeing things get incrementally better, I hope. So, anyways, that's my 2 cents. Okay? I think we'll move on to Kristen. Thank you so much.
Pleasure.
Good talk.
I promise mine is not nearly as technical.
But it's technical.
Kristen Rathjen, ScienceWares. So what I put together is a very, very broad overview of the concept of IA buffer zones or septic setbacks. As Steve said, what other communities are currently doing as far as implementation, other communities that have similar characteristics to Falmouth and Cape Cod. So for the purposes of this discussion, the buffer zone is a distance from a surface water body which within a septic upgrade would be required, or sewer if it's available. So buffer zone distances are typically based on groundwater travel time, soil permeability, how much nitrogen attenuation is possible, the local hydrology, or as Steve has said, any round number pulled from the sky. So some of the common threshold buffer zones range anywhere from 150 feet to 1,000 feet for any wetland resource area. So that includes all surface waters, so not just your tidal surface waters. So within 100 feet, that's covered under the Wetlands Protection Act. Anything beyond that is a local or regional regulation. So some of the towns around here that have implemented buffer zones, Wareham, they have a buffer zone between 150 feet and 500 feet. They have also stated that there will be no new systems within 150 feet. But in that 150 feet to 500 foot buffer zone, that applies to new construction, increase in flow, or any failed system that's being replaced. That applies to any surface water, again, so not just tidal waters, so rivers, streams, lakes, ponds. And their performance standard for that regulation is 19 or better. In Mashpee, their buffer zone is within 1,000 feet. They've got new construction, increased flow, or any other installation or upgrade of a system. And they are also any surface water, but beyond that, pretty much any wetland resource area, so any bordering vegetated wetland, salt marsh, inland coastal banks. The buffer is 1,000 feet for all of those. Performance level of 19 or better. In Tisbury, they have what they call the watershed district, which is pretty much whatever portion of the equivalent NSA is out there that's not in a sewer area. So that is, their triggers are new construction, any replacement or upgrade of an existing system, increase in flow, or property transfer. So again, that's anywhere in the watershed district that's not in a proposed sewer area. And their performance criteria is 13 or better, or showing 75% nitrogen reduction. The town of Barnstable has a committee that meets about monthly, which the initial goal of the committee was to advise for updating the CWMP, but they are talking about all of these IA regulations and watershed plans out there. That committee is proposing to town council a 1,000-foot buffer zone outside of their planned sewer areas. And their planned sewer areas have been well-defined for quite some time. They haven't defined any triggers, but from what they've looked at, that 1,000-foot has the potential to impact 2,100 properties. They are also looking at any surface water, so again, not just tidal surface water. And they are sticking to whatever happens to be on the best available nitrogen-reducing technology list. So Long Island, again, similar to Cape Cod conditions. Out in East Hampton, they have defined sensitive environmental zones. So they claim to be defined by groundwater travel time and the proximity to the surface water. And they say that generally covers properties within 1,000 feet. I didn't find any science behind why they ended up there, but that applies to new constructions, any expansions, or system failures. Again, it's roughly 1,000 feet from any surface water body, and the criteria on Long Island is 19 or better. Brookhaven, their buffer zone is 500 feet, which is new construction or substantial renovation, all surface waters, and a performance level of 19. So the Chesapeake Bay has done a little bit more work, not necessarily has all the science behind it, but they also have 1,000 feet of surface waters, but they also have 200 to 500 feet of any open channel MS4. So that's the combined sewer stormwater systems. Their triggers are new construction and any system replacement. Again, all surface waters. So their performance criteria is 5 milligrams per liter if you're between 100 and 200 feet, and anything from 200 to 1,000, it's 10 milligrams per liter.
What do they use to get 5 milligrams?
Yeah, I was wondering the same.
The same place they get the numbers from.
I don't know what their top system is off the top of my head.
We ought to find out.
Yes. I'm sure it's not one that's used in Massachusetts, clearly. For Falmouth, our new regulation is anywhere within a nitrogen regulated area, and it's for new construction and substantial renovation.
No, not substantial renovation.
Okay, I take that back.
So we can cross that off?
Yeah, you can cross new flow.
New flow.
New flow. Whoops. Within the nitrogen regulated area, those are the nitrogen sensitive areas. Any nitrogen impaired watershed that's on the 303D list. Districts of critical planning concern, public and private water supply protection areas, natural resource protection areas, drinking water resource protection overlay. And town of Falmouth is 10 milligrams per liter or less. So, as I said, Chesapeake Bay has done a little bit more trying to put some science behind it. So the paper that I sent to the committee, this is one of the tables that came from it. The state of Maryland has agreed to these nitrogen delivery factors for what they're using for their modeling. So they say within 1,000 feet of tidal waters, you get 80% nitrogen delivery. So that's pretty much equivalent to what we use up here. We apply a 25% attenuation factor to all of our septic systems from the MEP report.
Is this, is delivery 1 minus the attenuation in the ground? Or is it something about the IA?
It's all, probably all of the above.
If the
Yeah.
concentration going into the subsurface absorption system is 85 milligrams per liter, they're saying 80% of that 85 milligrams per liter is going to get to the water body.
There's 20% attenuation.
Right.
Yeah, so it is 1 minus the attenuation.
Right. Yeah, so they're saying 20% attenuation. Here, we say 25% attenuation for Title V. So they say within 1,000 feet of other waters, non-tidal, you get the 50% attenuation. So that's, again, if you're freshwater, you've got the pond attenuations. And greater than 1,000 feet from any water, they're saying that there is a 70% attenuation, so a 30% delivery. So again, I did not do anything in depth. This was just very high, back of the envelope. So Cape Cod, the groundwater velocities are typically cited at 1 to 2 feet per day in general. If you look at the watershed delineations and where your less than 10-year travel time line is, which was delineated by USGS, and you draw a line from the surface water, and you divide that by 10 for a rough estimate, knowing that it's really not proportional in there, you get about 1 foot to 2 feet per day. I've also seen local ranges cited at anywhere from 1/2 foot to 2.5 feet per day. So for the next round, those are the ranges that I use, so kind of more on the extreme ends. So if Falmouth were to put a 1,000-foot buffer zone on any surface water, only within the DEP designated nitrogen-sensitive areas, this is what the map looks like. So you have almost 16,000 parcels that are in those, in 1,000 feet of any surface water. When you take out the ones that are already sewered or plan to be sewered, you have about 10,600 remaining. So if you look at the groundwater velocity, again, the 1/2 foot to 2.5 feet, your travel time roughly could be capturing at 1,000 feet anywhere from 1.1 years up to 5 years and less. So from the surface water that that parcel is near to, not to the estuary. If you look at 500-foot buffer zone, because why not? That's a nice round number as well.
I like your logic.
Science.
I mean, a couple years ago, we looked at 300 feet,
Right.
so why not pick a new number? So 500 feet, you see we're down to about 10,000 parcels instead of 16,000 parcels. When you look at what is proposed for sewering or already sewered, we're back to another 6,600 parcels, which is the same number that we came up with in the geo-boundaries of number of IAs.
Yep. So I had a question about, this seems to be the same as the geo-boundary exercise in a way.
In a way, except the geo-boundary, like up here in Great Pond where you got Coonamessett and Jenkins Pond, those weren't part of the geo-boundaries because the geo-boundaries started from the estuary and went north. So this is any surface water, then also including Coonamessett River, any of those ponds, but it is very similar.
Yeah,
You're not wrong.
I don't think what you've, correct me if I'm wrong, but I don't believe you've yet said, okay, if all of these parcels got IAs and these areas got sewered per the Comprehensive Wastewater Management
Right.
Plan, what would be
Yeah.
what would be the shortfall that we would not make the TMDL?
Right.
So
So
that
there's
was
been
my
no-
next question.
Right, there's
So
no
what-
evaluation of
Because that was
this.
what was nice about the geo-boundary approach, is that it was tied to the loading.
Right. I'm getting there.
Okay.
Patience. So if you're looking at parcels that are 500 feet away, using the half a foot or 2.5 foot per day of travel time, that's anywhere from 6 months to 2.7 years of travel time from to the respective surface water. Again, that is not anything actually evaluated. That's just a very rough estimate. So what I did, to Ken's point, back earlier this year, there was funding from the Natural Resources Nitrogen Sensitive Area for a couple of watersheds. One of the watersheds that was looked at was the cluster of Megansett, Fiddler's Cove, and Rand's Canal. Within that funding project, GHD calculated updated septic nitrogen loads for all of those estuaries. And what I did was took that to how much nitrogen removal had to be done to meet the TMDL for today's water use numbers. So the parcels in light green are parcels within 500 feet of a surface water. So that includes the ponds and the estuary. This blue, this dusty blue color, that is what came out of the grant funding of what parcels would be needed to upgrade to IAs if you were also considering the alternatives. So the shellfish, the fertilizer, and the stormwater credits. So the red areas, those come from the surveys that Marine and Environmental Services did as far as shellfish suitability. So those are the areas that are currently being pursued as part of the townwide aquaculture plan. So I also looked at it on a sub-watershed basis. The MEP has the recommendations of how much should be removed from certain sub-watersheds. So that's why placement may look odd. But the parcels in light blue, if you get all of the other alternative credits, is what would be needed to meet the TMDL under current data. For the
Just stay where you were for a second. So that graphic is saying that under a watershed plan, roughly half of the area, if we just arbitrarily use 500 feet, would need to go to IAs. So forcing everybody to put IAs in just based upon 500 feet for at least this location is overkill.
yes.
Thank you.
Kristen, while you're on that again, because the disparity between the two branches of Rand's Canal really stand out
So
here, so,
with the shellfish and the fertilizer credits, and because you have Cedar Lake that does a tremendous attenuation potential, with all of those alternatives, you don't need to do anything on the North Fork to meet the TMDL, according
but
to
how
the
do people
numbers.
decide? I mean, you're going to have people on the southern side of things here pretty unhappy that their next-door neighbors.
That's the poster child for the fairness argument.
Yep.
Duly noted.
And
in
again,
my notes.
it's,
Yeah,
you've got the sub-watershed lines in there.
Yep.
Just following
Yeah, no,
what
I'm
those
watching
lines
them.
tell you.
yeah, I'm watching them.
So if you look at basically what the updated geo-boundary, so the contingency plan would be without any alternatives, so no fertilizer, no stormwater, no shellfish, again, on a per sub-watershed. So it's the same parcels in light green that are the 500-foot boundary. The dusty blue is what you need to achieve the TMDL for both forks. And this purple color which is what the original color is, but when you put it on green, it makes dusty blue. Those are additional parcels that you would need to get to the TMDL for the Southern Fork because of the sub-watersheds that they fall into. And that specifically, these are in different sub-watersheds than these are, which is why these ones aren't included. So that's what it looks like for this watershed. So, as I said, and as Kevin said, and everyone has said, there's the scientific rationale for establishing certain buffer zones seems to be lacking, or it's really, really hard to find what was used for establishing the regulations. A one-size-fits-all approach, so 500 feet, 1,000 feet, may not be appropriate for every watershed, but every watershed could certainly benefit in some way from a standardized buffer zone. It may not be enough to meet the TMDL. It could be overkill. Each watershed pretty much needs that individual evaluation.
Can you backtrack to your draft? Come back one more. There, good. You chose 500, but if, that to me looks like that might, if the initial number was 200 or 250, you might be not overshooting by too much. I mean,
It depends whether people follow the fertilizer reduction and whether the shellfish die that year or, right.
Understood. But, the Board of Health is going to, at some point, have to wrestle the outcome of the watershed plans, and we'll see where that all goes. Okay. I'm going to start all the way at the far end with Jonathan.
Yeah, I get back to Kevin's paper and the data. And when unfortunately, his data ends at 3,000 feet away, so all these limits are much closer, 1,500. But the spread he gets is from 0 to roughly 45% attenuation. And that's real data. So I understand what you're trying to do here, and that makes a lot of sense in terms of meeting the TMDL. It almost says you don't need a buffer. It's like, what do I need to do to get the nitrogen down so I meet the scorecard that we have to achieve?
Yep.
And by putting buffers in, that's almost causing the problems where, people are within a buffer, but one part of the watershed has to do it, the other part doesn't. Then there's a lot of explanation that has to occur, a lot of education of the people as to why, the neighbor's spending $45,000 and I don't have to spend anything.
Yep.
But the bottom line is you're trying to get to a TMDL on a contingency versus a non-contingency set of plans.
Yep.
Irrespective of what the buffer is.
Tom?
Couple ideas. The definition of an alternative is anything that's not sewering or a septic upgrade. Is that correct? All of our
Yep,
alternatives that we've all
PRBs, yep.
talked about. And this is half serious and half not serious. But
Are we supposed to be able to tell which?
I'm not going to smile during the serious part.
Yeah,
Try
50%
not to
chance of
smile.
being right.
But we could solve a lot of explaining and not worry about a lot of science by deciding what our TMDL reduced need is in each watershed. And given our citizenry fondness for something called Powerball and Mega Millions, we could have a lottery. And whatever the lottery blesses your property with travels with the deed. And think how that would simplify explaining to people that are on the edge of their seat wondering, why do I have to do this? And my brother-in-law is laughing to himself over here, and I'm being unserious here, that he doesn't have to spend $45 or what in a few years is going to be $65,000 or $85,000, because it's not going to get cheaper. It's only going to get more expensive. But anyway, just I want to throw that wild card into the
Oh, I appreciate that.
deck for discussion.
Go ahead, Steve, you're next.
Another plug for my 1 year at a time for a 20-year plan. First, because I think Jed made a really good point, and because I don't think gambling is better than rational fairness. if you do it in 21-year tranches, the rate of installation per year is the same as 4 5-year tranches. Because in the 5-year tranches, you're not going to all put them in the first year or the 5th year. You've got to spread it out from, just because of the limit by the number of plumbers and backhoe operators. And if you do it every year, you increment it, you start with the ones really close, who are getting the most benefit because they have the waterfront property, and where you think you're going to get the biggest effect, and generally expensive houses too, so it's sort of a socioeconomic fairness angle. But also you get your scientific data every year. You, especially that first group, where it's going to get into not get into the estuary very fast, your measurements in the estuary will be available right away, and then even the second group is not that much further away. And you can begin to plot all kinds of wonderful graphs and begin to predict where you're going to stop. Whereas if you do it in 5-year increments, then, okay, you have to wait for the 5 years to end, and then a couple of years to evaluate the data, and by that time, you're already, the second 5 years, you're halfway through the whole thing. That's all.
The fertilizer component, so that's assuming that across the entire watershed, there's a fertilizer regulation that's reducing fertilizer loadings to all the parcels in that area, right?
Yep.
You probably don't know the number off the top of your head, but be interested to find out, to be able to start to quantify the overall value of a fertilizer rule in terms of these number of pounds come out, the total cost, whether it's, 100 parcels at 45,000 versus 400 parcels at 45,000, because the fertilizer credit is real, but it's extremely difficult to implement because people will fight it at the State House level, tooth and nail. The one place where they've sort of done this is down Cape, where they had a couple of big golf courses that they were able to convince to change, and people are trying to monitor where that's at and if they're being effective. But, I'm just thinking that of things that we look at over the next several months, one of them might be to choose one of these little areas and try to quantify, what does it mean for fertilizer reduction, and what's the sort of benefit, the dollar benefit inside that, because I think we're going to need to be working really hard to educate people about why a beautiful lawn is allowed to turn brown in August because it's hot out and it hasn't rained. Saves water, saves fertilizer.
Kristen and I exchanged emails last month before I had to go away, and we talked about the Cape Cod Country Club and did some calculations on how much, I think it was 215 kilograms per year of nitrogen that's not going to be delivered.
Right.
And then if you take 2.7 kilograms of nitrogen per house from an IA, you can calculate how many homes will not have to go to IA because we're having less nitrogen being delivered by the golf course fertilization. That's probably the most quantitative thing that I've done.
Yeah, and we learned today that because that golf course is so far away from the estuaries we're concerned about, it'll help the ponds over time, but probably not the estuary. Okay. So.
Just
No, I'm trying to march down here.
right, a quick aside, though, aren't the golf courses required to use slow release, so-called organic fertilizers?
I think the answer is yes.
I think in Falmouth they are.
The answer is yes.
Yeah, but I think still the nitrogen is going to go down.
Yeah, but it changes the
They're putting
amount that's released.
25% attenuation in there, or 75% attenuation, only 25% nitrogen is credited.
Let's keep main conversations going. Yeah,
There's a lot to digest here, but to think about what are we trying to accomplish as a community, as a committee, an advisory board, to the select board, which would set policy. All those existing mandates from other communities that you showed as examples, their impact probably will be, as Falmouth's is, the order of magnitude of 100 systems a year. Not very many. And there are currently, surprisingly, over 3,000 IAs on Cape Cod. Some good, some not so good, and some useless. But that's a huge number. There's something like over 700 on Nantucket. But all of these new mandates aren't going to move the needle very much, and therefore will not impact the estuaries very much in my lifetime, maybe in yours. But this is a very, very slow process and may not work to the satisfaction of DEP. I think it's important to remember that the DEP default that really started people and communities thinking about watershed planning is, you don't do something, every house on that town will have to put in an IA. And Bourne, kicking and screaming, was finally dragged into the realization they better get on and submit a notice of intent that they will do watershed planning, otherwise everybody would have 5 years to put an IA in the town of Bourne. So that default mandate's still hanging out there. We're going to do, within the next year, a watershed plan to cover all the estuaries, as I understand it, and say, here's what we intend to do as our 20-year plan. And it'll be some sewering. It will say something about IAs, and it may just simply say, we will be evaluating on a rolling basis IA mandates. But if the mandates aren't accelerated to do more sooner, then the only thing that's going to help estuaries is the sewering. And that's, as we know, a very expensive and very tedious, long process. Within the next year, we'll start digging for Great Pond Phase 1. And then probably 8-10 years down the road, we might be doing Great Pond Phase 2. And in that interim, we might have done 500 to 1,000 IAs, but I think that's an optimistically high number, given the current mandates. So we need to think about what we're trying to accomplish. The bottom line is to clean up the estuaries, and if we don't do it effectively and the state's not seeing the results, they will drop the hammer. And even more importantly than that, we won't have clean estuaries for our children, grandchildren, and whoever come after us. So that's my pitch, to think about where we're trying to get and how this, it almost seems to me like we're trying to delay it and kick that can down the road. And the can will not get any cheaper and go any further if we don't move quicker. That's all I want to say now.
Ed, I did not know you were an optimist.
About what?
Ken?
So, I think we can debate forever, exactly how much the loading will be reduced by doing strategy X, Y, or Z, which is why I think somewhere along the line in the MEP process, they said, okay, we're not going to worry too much about the exact amount of attenuation. We'll give you some credit if the water goes into a surface water body, and that's it. And probably why I think DEP might be skeptical about fertilizer reductions, because how do you enforce it, and et cetera. So I guess my question, we started on this route, which I thought was very good, of these watershed plans that were grounded in the idea of meeting the TMDL. How much do you have to do to meet the TMDL, and work backwards from the shore, X amount of properties.
The contingency plans we saw over the last.
Right, X amount of properties are sewered, that's clear. We have a pretty clear sewering plan. I think it makes a lot of sense. And then if we also do this many homes on IAs, we get there. And we gave some credit for shellfish, as I recall. I don't know if we did much for fertilizer.
In the geo-boundaries, none of the alternatives were considered, because that was the contingency plan.
The contingency plan says you can't, if at year 5, you're not getting the reductions you predicted from shellfish and permeable reactive barriers and stormwater, et cetera, the DEP is going to say, you have to go
Well,
implement.
how do they know if you're getting the reductions?
That's a different question.
Right. So the other thing that pops into my mind, and Steve, you were talking about this, is, you know, a sort of adaptive approach as we add more homes, how much do we see reduced in the nutrient inputs? That, you only know that if you measure it, right? There's no monitoring plan that is routinely part of any of this.
I thought there's an annual monitoring of
the surface water.
Yeah.
Yes, of the surface water, but that's not necessarily telling you
That's the
whether.
bottom line.
It is the bottom line, but that can take a very long time to respond if you know, that might take 15 or 20 years for you to see. If you know you've reduced the groundwater by X amount and you've met your loading standard that way, then the rest of it is waiting for the ecosystem to, you know.
Well, the kind of monitoring you were doing, right?
Right, that's kind of my point, is maybe that should be part of what we're thinking about at the same time.
I mean, all of those
Stop.
IA
Stop.
systems.
Ken, your presumption that there is not going to be any monitoring is a bad.
No, I'm not presuming that, I'm just saying it's necessary.
If you, in the watershed plan, and what they talk about, there is an obligation to do monitoring, okay? So as the watershed plan is developed, there's going to be some chance to give input as to what is an effective monitoring plan.
Good.
Okay? So that's, I just wanted to be clear that we're not doing certain monitoring now, but the watershed plan is going to obligate us to do it.
The watershed plan will, I like the geoboundaries, and just adding to that, adaptive management and how far out in the geoboundaries we go will be tied to response of some X, Y, or Z.
Yeah. Okay. All right, audience? Comments, questions? No? From the audience? Okay. Steve? Oh, time out. Doctor?
George Topoulos, and I'm not representing the Board of Health.
Just state what precinct you're in then, and you're a citizen.
I think 3.
Okay, good.
I vote at the high school, so I think that is...
Google knows.
Yes, well, my son often says, Dad, if only there was a way we could find out. So first I have a question about fertilizers. Are the regulations you're talking about are for households as well as golf courses and such? I mean, there already is a regulation in Falmouth for, but if we don't know, if no one knows how much fertilizer is being used, you have no idea what regulating it, how much reduction you're going to see.
So inside the MEP model, there was a presumption, you know, based upon a broad view of how people fertilize or use fertilizer. It's not down to specific lots or whatever here, but the MEP model had atmospheric nitrogen, fertilizer nitrogen, stormwater nitrogen, septic nitrogen. Did I miss anything, Kristen? Those are the big 4, right? Right. So the model has got something built in for that. And I think Kristen just, when she was doing this, she sort of said, well, you know, here's another
Little bit we can,
you know, just
potentially.
Yeah.
But came from blue number, essentially. It sounds like.
It's a number from other.
That somebody else pulled from blue.
Was not specific to any estuary at this time.
And then in terms of having a lottery, I think most of the public is going to view the watershed plans as sort of a lottery in that you're going to come up with a number of houses, and then you're going to draw some lines as to where those houses are going to be. I just to emphasize what Stephen said before, I think this emphasizes the fairness question, and if you distribute the cost of everything that's going to be done as part of this, then the neighbors are the same, whether they sewer, do nothing, or put in an IA. And as Ed said, if we don't get on this, our great-grandchildren aren't going to see any difference in what's happening.
Steve, you had another comment?
Yeah, at the risk of bringing up a whole nother thing,
Don't do it.
there are these things.
Take a break.
There are these things called freshwater ponds. Did I hear Kevin say that if the nitrogen-laden groundwater first goes into a surface water, which, for instance, a fresh pond, and then goes in a stream down to an estuary, it's 70% attenuated?
Kristen, Kristen knows, because she's brought this up multiple times about this going through this water
Just for
body.
clarity, I didn't say anything about it.
Oh, sorry, somebody said it.
In the MEPs, some of the ponds they actually studied and assigned a data-based attenuation. Others, they arbitrarily assign a 50% attenuation for freshwater.
Because to the extent that that's a large percent, it tells you that it's a waste of time to put things around a freshwater pond. To the extent that Kim Comart is here, it would drive the people that live there nuts if we went along that.
Well, don't forget, that's for
It's a
nitrogen.
conflict of interest that we need to address.
Yeah, we were working on it. Okay. Any more comments? Thank you. This was, again, thought-provoking.
Yes.
You know, just to help everybody who is in the audience and/or maybe watching this at 4 o'clock in the morning because they can't sleep. It's on MTV or whatever we have. So the estuaries that are on the Buzzards Bay side are by and large areas that we're not going to have any increase in sewer potential for. Whereas as the outfall keeps progressing forward, there is a potential to expand the areas that will be sewered for the south-facing estuaries, which again would impact the extent of IAs that have to go in. So there's kind of two distinct groups of estuaries that we keep looking at. Kristen chose the Rand Canal one because, A, the scale of it's pretty easy to work with right now, and the number of variables are probably more manageable.
We had updated numbers, too.
Yeah. Okay, nice. All right. The next item on our agenda is a recommendation to support the Board of Health memorandum on fair distribution of costs in Falmouth's efforts to meet water quality targets. We had something on this before. It went back for a rewrite. I got an email mid-afternoon from Ken, who has some thoughts on this. So do you want to start off, Ken, with where you're at on this?
This was the letter about fairness.
Yes.
Well, I just thought it was overly wordy and indirect and could have been stated more succinctly, but I liked the overall sentiment of it. So not wanting to violate the open meeting law, I only sent it to Kristen and you.
Correct.
But I did produce, I can send you my revision. I'll give this one to Steve because
I might make this sort of suggestion. So two members of the board can communicate.
the other Steve. You can have this one if you want.
But I guess
I mean,
what I would say is,
I made 3 copies.
we don't have to vote on this tonight. We could table this, okay?
Yeah.
Steve, you can look at what he wants.
Can I say something first?
Yep, let me finish what I'm saying.
Okay.
Okay. And then we can bring it back up at the next meeting, okay? We do not have.
I'm not saying okay till I get to say something.
Okay, go ahead.
There was an original version of this. I sent it to Tom and Ken because they're our best editors. They came back with some good suggestions. We put it in. It came up at a meeting. Ed had a substantial objection about sewers. I let him put in everything he wanted to there. And then you send it to Amy. She made some changes. We put those in. The whole point of this is not to make the decisions. It's simply to alert the select board that as soon as possible, they should appoint some sort of committee, which might be this one or a subset of this one, to look into this area. So I really don't want to waste time arguing over even another delay on the, just for grammar purposes.
No, it
when
wasn't
the point
just
is
for
to
grammar.
get it to the select board as soon as possible.
I agree with you. It wasn't just for grammar. And when I got here, I showed it to Ed. Can I say that you thought it was okay?
I didn't see a great deal of difference between Ken's thoughts and what you and I, Steve, had agreed to, Steve Layton, not you, Steve Rafferty, and submitted, and then Amy put some things in. I think we're there.
So I think,
Chris,
I
wait
move
a
that
minute.
your version be passed right now.
I'm sorry?
I make a motion that we vote on the most recent version from Ken. I haven't
you
even
read it?
I haven't even read it.
No,
I
nobody's
think
seen
you ought to
it.
read it.
Chris, can we put up, Kristen?
Just a time out. He's made a motion. Is there a second?
Sure, I'll second it. I wrote it.
There's been a motion made and seconded to send a letter on fairness to the Board of Selectmen.
I really do want to read it, but
Yeah.
Discussion.
So Steve,
Does anybody want to have any discussion on this?
Discussion. Can we put up the version that was there prior to Ken's comments tonight, that was an input of Mr. Layton and myself, and Amy had some things, and that, I don't see a great deal of difference, but if we could put that up, people take a look at it, and then, I don't know if you can put up Ken's, and then we could vote.
I think I sent it to you, didn't I?
Yep, they're both up at the moment. So this is the original one that went around as a meeting item on Monday.
Right, and
Okay.
okay, so that's what I was responding to. And I wasn't trying to change the meaning of anything, I just thought it could be stated with about half the words.
I just read it and I have no problem with it.
So Ken's version, this is Ken's version without any of the edits,
So-
but with all the typos.
Yeah, well, you have to fix it.
You're going to do a clean copy, right?
This is
the clear.
that's mine. That's the original.
You need an extra?
Did you have something we
So
accepted?
here's the
Did
difference.
you-
That's the red line version. Flip it over, and I accepted all the changes.
All right,
That's what it looks like.
so for everybody's benefit, the document currently before us for a vote says, to the Town of Falmouth Select Board from the Water Quality Management Committee. The Water Quality Management Committee supports the recent memo from the Board of Health to the Falmouth Select Board, urging the Select Board to find the fairest way to spread the costs of sewers and IAs among the town's property owners. Falmouth's efforts to restore the health and well-being of our coastal embayments will be expensive, but are necessary and benefit our entire town. However, an inequitable distribution of costs among property owners in Falmouth could reduce support for the town's nitrogen reduction and watershed planning efforts. The Water Quality Management Committee, or a subcommittee of the Water Quality Management Committee, volunteers to serve as the designated group to examine and evaluate options for fairly distributing and easing the financial burdens of implementing wastewater mitigation. Such a subcommittee should also include representatives from the Finance Committee, the Board of Selectmen, and the Board of Health. We acknowledge that no plan can be perfectly fair due to varying property characteristics, property owner circumstances, implementation timeframes, and the complexity of the expected overall watershed plan. However, the committee should endeavor to prepare a fair and simple financing plan that accounts for factors including hardware, installation, connection, operating costs, and sewer fees, as well as tax credits, residential tax exemptions, low-interest loans, betterments, and direct and indirect benefits and costs to property owners. Finally, any cost-sharing or financing plans should be created concurrently with the development of the watershed plan so that the finance plan can be integrated with the rest of the town's long-term capital budget and to win community support.
I move we accept that as displayed up there. And I think, well, was that your motion already?
That motion's been made.
That's right.
Motion's been made.
What was your motion?
Come on, we're procedurally, motion's been made, seconded by Ken, and
we're
we're now in a
discussing.
discussion
That's
thing.
right.
I just want
Yep.
to, rather than having people try to read the thing off the screen, or people are at
I
home.
like what you did there.
I would make a friendly, can I make a friendly amendment, or does somebody else have to do that? I just, the second, there are 3 paragraphs. The second paragraph, the last sentence, such a subcommittee should also include, I would prefer to change that to could also include.
Well, we're making a recommendation, and if we think it should be a certain way, we should say should.
I agree.
I want to leave that up to the select board.
Well, aren't they looking to us
It
for
is up to
advice?
them. They're just
It is
taking
up
our
to them.
advice.
We're just saying should, not must.
Okay. Whatever, I'll.
I mean,
do
don't you
whatever
believe
gets
that it
this
should?
out of this committee. I vote for could, but I can see that that's
I was
not
trying
gonna
to,
fly.
I was trying to channel you. I thought, Steve thinks it should.
There's an amendment that's been proposed. Is there a second on the amendment?
I thought Ed seconded
No.
Steve's.
No, nobody did, so
Okay,
it
so
died.
not hearing a second on the amendment. The amendment is dismissed.
Oh,
Procedure.
I see, you're talking about this most recent
He
amendment.
just said, he proposed an amendment.
Yeah.
Right.
So we're just moving ahead with any discussion of the seconded motion to support it as written by Ken.
Okay.
Edited.
Is there any further discussion
Yes.
on the letter that I just read?
Yes.
Go ahead, Tom.
Couple of things. I would change the fairest to a fairway, because I think you're setting an impossible.
Golf course?
Yes, exactly. One with slow release nitrogen on it, but no, I would just change it to a fair way instead of the fairest, because you're going to get into intense discussions about what is the fairest way. Also, I would spell out.
You're on the second line, correct?
Yeah, the second line in the draft. And then in the second paragraph, I would do the select board, not the Board of Selectmen.
Yes, I know that.
Spell that out, and also in honor of the gravity of the Board of Health, I would spell out Board of Health. And I think that's it. The earlier draft had an extra paragraph in it. Where is, wait, let me see if I can.
You combined it.
Find it.
I might have put in a,
No, it wasn't one you did. Finally,
I think I put a paragraph, extra paragraph return in there.
yeah, I think, yeah, no, the new, your draft doesn't have the sentence that had the extra paragraph. I'm done. I'll quit.
Steve, we could shorten this by accepting his suggestions.
Yes, I would also like to point out that I sent it to you two guys first.
Right.
To prevent exactly this waste of time. I'll go ahead with whatever you want.
Okay, Jonathan? So momentarily, that, you're proposing an amendment, okay?
Yeah.
Okay. I think.
Those minor changes.
I think expanding the BOS and
Of course.
BOH, that doesn't have to be amended, but you're basically asking to find a fair way.
Yeah.
Okay,
I'll second that.
okay? So there's been a motion made and seconded to change in the second line, the fairest way to a fair way. All those in favor signify by saying aye.
Sure,
Aye.
yeah, aye.
Okay. All right, go ahead.
I fully support the letter. I'm just concerned about the last sentence of it on the timing of this plan relative to the construction of the watershed plans, which I understand will be done this year. I think this is going to be a very complex issue, and it'd be great if it's ready for when the watershed plans are, but knowing what I've seen, it may take a long time to hash this out to a final plan, because we're talking significant amounts of money that are going to be in discussion. I don't know how that gets voted on. I'm just concerned that the timing tied in. It would be great if it happens. I don't think it's a must-have.
Well, don't forget, it's a recommendation.
Yeah.
It's
Yeah,
not a-
It's a should be, not must be.
I just want to, I want to address your concern. In the watershed plan, there is a component to look at the costs and the ability to finance it. So there's already in the watershed plan. What Steve is advocating through this is that from the outside looking in, we try to identify how to make things fair, okay? Because it's not necessarily true that the watershed plan is going to pick up the fairness mantle, okay?
And one of the purposes of this,
It is a big lift.
also one of the purposes of coming up with a fair plan is to get support for the watershed plan.
Right, very good.
I agree, just the timing is what concerns me.
That's what I'm speaking to.
It'll happen.
How do you use it to get support if you don't have it?
Kevin, please step up to the podium.
So I wrote the over wordy and whatever other draft. Yeah, that was mine. But no. It's I agree. But I understand what you're saying, Jonathan. To me, that seems like it's going to take. I mean, it's extremely complicated, and it's well described in the letter how complicated it is. But at the same time, I wonder, can we actually start to implement a plan before we have all of that worked out? Because we're going to go to the first homeowner and say, it's you got to put in a system, and we don't know exactly what benefits they may or may not get. You know, we have to have the formula worked out before they can pay for it, I think. Just a thought.
It will behoove this special committee to work as fast as they can and no faster.
Yep.
And the committee will only be
Work
making
faster than
recommendations.
you
They're not implementing policy.
Right.
Okay? I get the doctor.
Oh,
From precinct 3,
From Precinct 3, we
we
believe.
welcome the doctor.
So I would make the suggestion that it would be good, in fact, to have the fairness plan before the public knows what the watershed plan is, because one of the ideas about best ways to develop fairness plans and have them supported is that the people who are deciding if it's fair or not don't yet know what group they're in.
yes.
Because of human nature, we tend to want to vote in our self-interest even if we're not aware of it.
Thank you. I have a procedural question. I feel as though, you know, we seldom put something this formal in writing to the Board of Selectmen. So I would say that we all need to, we could take a vote, but we all probably should be signing this eventually.
Yeah.
Okay? All right? So
Yes.
we're going to find
Yes.
a pathway to sign it, whether that's something come back at the next meeting, we all sign it because we made the edits and whatnot, okay?
I agree.
Okay. All right.
Just quick comment to the Dr. George's comment about, you know, we should do this because, you know, when people see it, they're going to say, well, which group am I in? We've already put people in a group. There is an IA mandate already established. There are over 300 IAs currently in Falmouth. They didn't get any extra help. And the recent mandate of new construction increased flow has no subsidy component. Pretty much any other community in the region, including the islands, don't have a subsidy, with a couple of limited exceptions with very limited available funds. So the horse is out of the barn. The mandates are there. How do you say to the people that have to put one in next month that you now are going to subsidize those that get it a year from now? The horse is out of the barn. And Mr. Chairman, I'd like to move the question. Let's vote.
Okay. Oh, is it going to be like David Vieira where you
Yes.
can't say anything? You said too much. You can't move the
Of the
question.
letter as amended, signify by saying aye.
Aye.
Thank you. Okay. The next item on the
You have to
agenda,
move the question. You can't say
the next item on the agenda, I'm going to ask for a motion to table this till the next meeting, because we are at 20 past 6, which means we have 10 minutes for reports of members and staff and to vote minutes of prior meetings. Can I get a motion to?
So moved.
Okay. So all those in favor of tabling item 4 till the next meeting, signify by saying aye.
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 Yes.
Now, we're going to move on to reports of members and staff, and I am going to take one moment to touch upon the Water Infrastructure Investment Fund, because it's been pointed out that perhaps we've misspoken as to what the WIF is. I want to clarify that currently the town raises, through the property tax, about 100, for this year, they're estimating about $127,884,366.
Roughly.
Roughly. And the percentages applied to the property tax, not to raising the overall tax rate by 3%. So it talks about raising more revenue than the amount of revenue currently being raised. So that's a 3% increase in revenue, or a 2% increase in revenue, or a 1% increase in revenue. That's the clarification. So, reports of members and staff, I have one item. Roughly a week ago, the town took bids on the T-ticket Phase 1 sewers. The good news is that we got multiple bidders. The even better news is that all of those bidders, and particularly the low bidder, are measurably below the budget. So that means that as we move into calculating what the betterments are going to be, the estimated betterments we've had floating around are likely to come down by a certain factor, whether that's 5% or 10%. I don't want to venture too far out there yet, but in the bidding environment we're in, it's good to know that people are interested in working in Falmouth.
Yeah.
And so we are in the award stage right now. This will get awarded probably over the next couple of weeks, or the first or second week of January, and construction will start up probably late January or early February, and will continue through for about a year and a half. So the good news is the estimates were good, the market is good for us, and we're not staring at any shortfall in the funding, so that's what I have for reports, for my report on that. Ed, you usually have something to report.
Sure.
Do you want to cover the folks on Sandwich Road? You requested some information.
Got some information, but it wasn't much, that, the Easterly has applied for their groundwater discharge permit for a system to serve the 300-odd apartments. The proposed permit that the DEP will be issuing, because it seems to be a foregone conclusion, they will issue it, is for 10 milligrams of nitrogen. Not what the town wanted 5, and they're going to try for 5, but they're going to be required to meet 10.
I'm going to clarify this, okay?
Okay.
No, I will, just because they are obligated to have the system perform at 10 or less. If they exceed 10, they're in violation. However, there is a total pounds of nitrogen annual limit. That annual limit is based upon 5. So they will need to run it at 5 or better for most of the year to make their annual limit. But,
How often do they have to report?
Yeah.
There's a monthly report.
Monthly.
I'm sure there's a monthly report.
Yes, it's a monthly.
I could reread it, but,
Yeah,
so,
no, it is monthly.
they didn't turn around and say you must treat it 5, but they said your annual average has to be 5 or less.
They must treat it 10, but they have to average 5.
10 is the upset, so discharge permits typically, like on the outfall or whatever, they'll tell you,
I know. I was gonna give it to
you
Chris.
can't exceed a certain number ever, but, overall, the total has to be below something, okay?
Okay. One other thing, if I may. On the PRB project for Snug Harbor, which we have a grant in place and a number of in-kind contributions from various entities to make that thing happen. Salt Pond Area's Bird Sanctuaries, which is their formal name, who is an abutter to the project, has signed an agreement to allow access to their property. We need a signed agreement from one other for a minimal plan we worked on just this morning for some various reasons. But I think an important thing is for people who may want to donate to the project and possible extension of the length of the PRB, Salt Pond has agreed to be a designated nonprofit organization that would accept donations earmarked for the project, and then they would use those funds to directly pay vendors. It's the simplest way to get around a lot of restrictions on donations to the town and soliciting donations. So it was a very generous gesture, and took a while to discuss this and get Salt Pond to agree, but they have just this past week said, yes, we will be the designated donor recipient for that project. So We've got some issues to work out on and hopefully get into the Concom agenda in the next couple of months. That's it.
Thank you, Ed. Jonathan, do you want to do an update on the House bill? Or did you did you see Dave Vieira's note?
Yeah, there's a delay for 1 month. It's House Rule 27, so it was supposed to be December 16th. Now the decision on the bill will be January 16th.
So I would like to reach out to all the members of the committee. I'll try to get an email out tomorrow or whatever. We need to do what I would call the next level of outreach to any organization or group on the Cape that we think might be impacted to say, now is the time to drop a letter of support in favor of this article. We've got another window to push another group of people to chime in, okay? So, Tom.
I wanted to circle back to the Saxon issue. How rigorous is DEP on enforcing
They are.
regulations, and what sort of penalties are involved?
I don't know the penalty scheme right now.
And they're saying,
Okay.
this guy will sign.
I don't have that in front of me.
This is 10.
But I do know that.
But as long as they're rigorous, because,
For example, they've come back to the Seacrest once or twice because their system wasn't performing, and they had to get somebody in and upgrade it. And similar to what the Board of Health did with the glam camping, just, the
Right.
numbers aren't there, you gotta fix it. So,
good. All right, thank you.
Any other committee conversations? Okay? Not hearing any? Go ahead, Steve. You want to
I
talk?
mentioned to you before the meeting that I was going to mention this.
Go ahead.
As you may know, Steve had to give the annual report to the Select Board on Monday, and so I listened to it on FCTV, and it was one more example of the fact that the chairman has to do 10 times more work than the rest of us, so we all owe him some thanks. But
A fool is born every minute.
And some of us thanked him already.
But no, that's not, that's just covering myself. It's true, but that's not my main point.
You got 3 minutes.
Okay, 1 minute for you. No, I'll take less than I think. I noticed 3 things from the comments of the Select Board to his presentation. One is on PRBs, but also on sewers and IAs. I think it would be useful if we had a printed version, maybe even on our website, or at least a document that we all knew, which had the range and the average nitrogen return on investment for these different quantities. Because otherwise you have people thinking, oh, this is the magic bullet. They're doing this research, they're going to come up with this thing and put PRBs everywhere, and we won't have to have sewers or IAs. And of course, we all know qualitatively that that's ridiculous. But we should be legitimate engineers and scientists and developers and have a kilograms per year per dollar figure for different, or ranges for different technologies, just to keep the conversation rational. The second thing is nitpicking, but I think it's in everybody's interest, that little pond graph of nitrogen concentration versus time. I thought we were going to fix that with fitting it with 2 lines, one before the sewer and one after. That's completely legitimate science, and it makes it look much better.
Ken Foreman gave a presentation at the SIP of Science, and we're going to ask him to come in because he's got several different ways of looking at the data, and it's clearer when you look at Ken's work. So he's going to be on a future agenda.
I did send you that figure, though. I don't know if you included it.
My timeline was...
Understood.
But it was good, Ken, and I really think it's something we're going to bring up at another meeting because it does really kind of bring the point home better.
And the last thing is that it was obvious to me from the comment of some of the Select Board members that they are not yet aware of the Board of Health letter.
Oh.
What?
Interesting.
Because I don't know the details of how they work, but I think that their material and agenda is set for them by town management. And town management chooses when that goes to them. Whether there's another channel, I don't know. I leave it up to anyone who wishes to.
Oh, nice. Can I get a vote on did everybody read the minutes? Are they good? Can I get a vote? Can I get a motion and a vote on the
I
minutes?
move that they be accepted as written.
Second.
All those in favor signify by saying aye.
Aye.
All right, can I get a?
Move for adjournment.
Can we express our thanks for the calendar?
Yeah,
Yes.
Thanks.
yeah.
I like the centerfold. Not everyone got the calendar.
And SIPA Science was very well attended, by the way. Ken and Amy spoke and did a great job and had a lot of people. I couldn't believe how many people were there. It was standing room only.
SIPA Science was great.
Yeah, and the beer was good, too.
There's one coming up.
It's all about the
There was
beer.
beer?
There's one coming up in another week or so.
Yeah, they've been doing them all fall, and I think it's been
Yeah.
pretty successful.
Yeah, and there's more in the works. I'm trying to, I talked to,
So I get an email from the Cape Tech Council now, and I'll circulate what I got the other day to everybody, okay?
Good.
So they list things that you can go to get a breakfast at the Cape Cod Community College and hear about carbonization in the soil or whatever, and, fiber
Should
optics,
do one on
whatever. So,
PRBs.
Yeah.
anyways, I have a motion to adjourn. Was it seconded?
Yes, it was. I
All
second.
those in favor signify by saying aye.
Aye.
great.